welcome to IPM Leap. Today's lesson is about a very important topic in maths, which is called the fundamental rule or the fundamental principle of counting. Let me jump to the rule straight away with an example, and later in this video we will see some practice questions which can be easily solved using this rule. The fundamental rule of counting says that if there are two actions to be performed in a sequence, where the first action can be performed in m ways and the second action can be performed in n ways, together the two actions can be performed in m into n ways. Let's say, for example, you have to dress up for a party. And dressing up for a party means that you will have to essentially wear a shirt and a pair of trousers, right? So suppose you have 3 shirts to choose from and 4 trousers to choose from. If I ask you, in how many ways can you select the shirt that you want to wear? So either you will wear the first shirt or the second shirt or the third shirt, isn't it? You can wear a shirt in 3 ways. Similarly, if I ask you, in how many ways can you select the trousers that you want to wear? So either you will wear the first pair of trousers or the second one or the third one or the fourth one. You can wear a pair of trousers in 4 ways. Now if I ask you, in how many ways can you dress up for the party? Which essentially means wearing a shirt and wearing trousers. Now assuming that there are no matching issues, which means any shirt goes with any trousers, then it's important to note that the choice of the shirt will not affect the choice of the trousers. In other words, these two actions of choosing a shirt and choosing the trousers are independent. So let me show you a graphic representation which lists down all your options. Okay. If you wear shirt 1, you can wear the trousers in 4 ways. If you wear shirt 2, you can still wear the trousers in 4 ways. Similarly, if you wear shirt 3, you can wear the trousers in 4 ways. So the various combinations for shirt and trousers looks like a tree diagram with so many branches. Counting the options, we add 4 plus 4 plus 4, which is equal to 3 into 4. Therefore, together, these two actions of wearing a shirt and wearing a pair of trousers can be performed in 3 into 4 ways, which is 12 ways. This means you can dress up for a party in 12 ways. So just to recap the fundamental rule of counting, if there is a first action which can be performed in m ways and a second independent action which can be performed in n ways, together these two actions can be performed in m into n ways. Now let's try out some questions where we can apply the fundamental rule or the fundamental principle of counting. The first question is, city A is connected to city B via 5 different routes and city B is connected to city C via 3 different routes. In how many ways can a person travel from city A to city C via city B? So guys, it's very simple. To go from city A to city C via city B, a person needs to go from city A to B first through any one of the 5 different routes, and then he needs to go from city B to city C via any one of the 3 different routes connecting B and C. So together, these two actions can be performed in 5 into 3, that is 15 ways. So there are 15 different possible routes from city A to city C via city B. Next question is, an ice cream parlour has 8 flavors with 5 toppings and 3 different sizes for the cone. How many options do the customers have if they want to order an ice cream cone? So, as it is clear from the question, ordering an ice cream cone is comprised of 3 different steps. We need to choose a flavor, we need to choose the topping, and we need to choose the size of the cone. Choosing a flavor can be done in 8 ways. Choosing the topping can be done in 5 ways. And choosing the size of the ice cream cone can be done in 3 ways. So together, these 3 actions can be performed in 8 into 5 into 3 ways, which is equal to 120. So a customer has 120 different options for an ice cream cone to choose from. And our final question is one of the trickiest and one of the most popular questions in exams. The number lock of a suitcase has 3 circular dials, each labeled with 10 digits, that is from 0 to 9. It is known that the lock opens with a sequence of digits with no repeats. So how many maximum trials will a person need to do before he is able to open the lock? So let's suppose these are the 3 digits which will form our combination for the lock. We need to fill 3 different digits in these 3 places. So the first can be filled in 10 ways using any one of the digits from 0 to 9. Once we fill this place, suppose we fill 7 here. That digit will not be used again because it can't be repeated. For the second place, we are left with 9 digits only. Similarly, after filling the first 2 digits, we will be left with only 8 digits to choose from for the third place. So together, these 3 places can be filled in 10 into 9 into 8. That is 720 ways. And there will be as many number of possible 3-digit codes. But in the question, they are asking how many maximum trials will a person need to do before he is able to open the lock. So if a person is very unlucky, he would have tried all possible codes and will be able to open the suitcase only in his last attempt. That is 720th attempt. And that's why the maximum number of unsuccessful attempts will be 1 less than the total number of 3-digit codes possible. That is 720 minus 1. 719 is our answer. That brings us to the end of this video. I hope you all are quite comfortable with the fundamental rule of counting now and have got a good enough base for permutations and combinations. If you like this video, don't forget to press the like button and do subscribe our channel for more such useful content. Good luck and take care.